Alrighty then, let's see what happens. So for this stream today, what I want to try and show off is Telegraf's metric buffer. So let's start with a little bit of background, I guess. Telegraf is a metrics collector that works with pretty much any time series databases and a few other non-time series databases. So it has the ability through plugins to go and collect some sort of metrics, perform aggregations or filtering on those metrics, and then output them somewhere. So let's start off then with a really simple Telegraf configuration, collecting some really simple metrics and just writing them to our console. It's probably the easiest way to get started. So first we need to generate a Telegraf configuration file. We can do this with Telegraf config and output that to a file. Now we're going to strip this right back to the complete bare essentials. So we're not even going to have any global tags. We're going to keep a few of the agent configuration settings. So right now we're going to have a collection interval of 10 seconds. That means for all of the plugins that I have configured, reach out every 10 seconds and grab the new metric. The round interval just means that it keeps your numbers like 0 seconds past the minute, 10 seconds past the minute, 20 seconds past the minute, regardless of when you start Telegraf. There are reasons for doing that, mostly around grouping and windowing when you query the data. For now, we don't really care about that. Now, we are going to play with the metric buffer and batch size, but first we just want to get Telegraf running, so we're going to keep them commented out. And then I'm going to jump down to here. And just because we're going to get a feel for Telegraf, I'm going to leave the debug setting on true. Next, I'm going to omit the host name, just because it's not important for the purposes of this, but this would allow you, say you're running Telegraf on every machine in your infrastructure, then a tag value would be added to every metric with the host name the metric was collected from. A, this scenario is a single machine, and B, I'll probably run it in a Docker container, so the host name isn't going to give me any value anyway. Now I'm going to delete everything else in this file. It's quite large because we have over 200 plugins at the moment. So there are like 170 input plugins, there are 70 output plugins, plus all the processors, aggregators, etc. So that's why everything in the file that we generate is an example of every plugin. So we're going to start without that. Now we need to collect some input first before we can output it anywhere. So for this, I'm going to use the mem plugin. So I just pulled up the docs for this through the GitHub repository. Telegraf, you go into the plugins directory, we're going to look at the inputs, and then I'll grab the mem. The reason I'm using this plugin is that there's no configuration. We just enable it, and it gives us some information about the memory usage on our machine, and the output format is relatively trivial as well. It's a single measurement with a bunch of fields. Now we want to be able to output that somewhere, so I'm going to output this to file, and we're just going to use standard out, and we're going to save this. So in theory, I run telegraf config, telegraf.conf. Every 10 seconds it should reach out, find out what the memory consumption is on my machine, and then output that to standard out. Now of course we have to wait 10 seconds, so start the awkward silence. No. So we'll just quit that. Now what's important about this output? So for the uninitiated, this is line protocol. So at the start we have the measurement name, which is mem, and then we have all of our values. There could be tags here, but it just appears that we don't have any. That's okay, but we have a lot of information about the data we're collecting on the memory, and then at the end we have a nanosecond resolution timestamp for when this metric was collected. We can see here that we have two metrics being written very, very quickly in 86 microseconds, and our buffer was flushed, and then I killed it. Nice and simple. So now we want to be able to store them somewhere. And to do that, I'm going to just bring in some Docker containers. I always use version 2.4 because I don't like version 3. It's focused on cloud deployments and Kubernetes and Docker Swarm, and you lose out on some cool functionality. I'll have another rant about that another day. But for the time being, I'm going to jump over to another repository, which is my InfluxDB examples. And I'm actually just going to copy the setup. Oh, that was the worst example to pick. Let's try. Yeah, this one's got quite a lot in it. So I'm just going to run InfluxDB1. And we will actually run Telegraf here too. So we will copy this, even though we don't need most of it. And we'll just call this Telegraf. We're just going to use the official image. We don't need any ports, and the only thing we need to mount in is our Telegraf configuration, which is just telegraf.conf. So now we should have InfluxDB running within this Docker Compose network under InfluxDB. Now, InfluxDB runs on port 8086, so we just have to configure Telegraf to write to that. Now again, we already have this configured here. So I'm just going to copy and paste this. The reason I'm using InfluxDB1 is there's no authentication, and it just saves me 5 minutes faffing around with that. So we're going to write to InfluxDB on the service name on the port. Now we also want to be able to visualize these metrics. I could do that through the Influx CLI, but we want something a bit nicer. So I'm also going to copy in our chronograph configuration, which is our UI. Come back over here. Chronograph, point it to InfluxDB. We can ignore the capacitor. We are going to expose this port so that we can actually browse to it. And this is just one of the reasons I like the 2.x syntax for Docker Compose, is that we can actually have conditional based objects. So let's spin all of that up. We'll do it in the background. Hopefully the images won't take too long to pull. Anytime you like. Might as well get comfy. Right, let's see. All 3 services are up and running. Telegraf should be still writing to standard out, so we can do Docker Compose logs -f, follow it. Yep, good, all working well. And if we scroll up here, we can also see that we have InfluxDB output. Database creation failed. You can ignore that generally. It happens again later. And we have no errors when flushing our right metrics, so InfluxDB should be receiving these metrics as well as the standard out. So what we'll do is we'll browse to chronograph. And click on Explore. We'll delete all that. We've got our memory measurement here. We'll do it like that. Okay, cool. There are no tags, so I can't filter any further, but let's take a look at our available. In fact, let's do the percentage stuff. So, used. And now we can see that our used percentage of memory is 30 and we have 63% available of memory. So we're now collecting metrics. Now, in order for me to explain the metric buffer stuff, we're going to have to get some internal metrics as well. So we're going to enable the internal plugin for Telegraf. And if we just pull up the documentation for that, you can see the internal plugin collects metrics about Telegraf agent itself, yada yada yada. We're going to collect the memory stats. Not important, but you know, configuring Telegraf plugins is relatively easy, just like that. So now we need to restart our Telegraf instance, and what we should see here is a new measurement. So let's do docker pose, restart Telegraf. And that's just to bring in that new configuration file. I could have exec into the container and done a reload, but the restart is just as effective. To make sure everything is still working, we're going to tail the logs once more. What we should see at the top, yep, as our internal input is now enabled, and we're still writing batches of metrics. So where we were writing 2 metrics before, we're now writing 7 metrics. And that's just those internal ones being added. So if we jump back over to our UI, give it a quick refresh, and now we have all of the internal metrics for Telegraf. Now the ones that I'm particularly curious about are going to be, let's just group by output. We have 2 outputs, so there should be standard out and file, file standard out / InfluxDB, and we can take a look at the metrics dropped, metrics written. So what have we got here? We have our metrics written to file 21, metrics written to InfluxDB 14, metrics dropped InfluxDB 0, metrics dropped file 0. So we're not dropping any metrics to either output, but we are writing metrics to both of our outputs. Good. So what is the metric buffer? So the metric buffer is a concept in Telegraf that means if any of your inputs are down for any period of time and Telegraf is unable to write those metrics to that output, is it will store them in memory, and it will store them in memory for as much as you allow with the metric buffer limit. So based on what we've seen from the console out, standard out stuff, we were writing 7 metrics every 10 seconds. So let's say that we are going to shut down InfluxDB for 30 seconds, if I can find something to talk about for that long. Then we're going to need a metric buffer of at least 7 times 3, because it's 3 intervals, which is 21. But we actually want to see some drop metrics as well, so let's just say that we do 15 per output. And that's always important to remember the wee comments here. This metric buffer is per output. If for whatever reason you were writing to 5 different databases and you had a very large metric buffer, say 50,000 or 100,000, then that would be a multiple of how many outputs you have, which would mean you're actually storing for 50,000 metrics. With a metric buffer of 50,000 and 5 outputs, that would be 250,000 metrics held in memory. And depending on the size and shape of those metrics, that could be quite a lot of RAM. So it's just worth bearing in mind. So now we need to restart Telegraf again with our new metric buffer limit, and we shouldn't see any metrics being dropped still, because nothing is broken, nothing is down. Perfect. So let's just tail the logs, wait till we see the first flash, and then jump back over to our chronograph. Awesome. So let's just turn on the auto refresh here. Let's say every 10 seconds, just as that's what our interval is. Although I guess if we're going to do if I'm going to force it to drop metrics, I may speed that up. So let's put it on 5 for now. 1, 2, 3. Okay. So you can see we're still writing to both of our outputs. This is going to gradually go up. Of course, our refresh is slightly faster, well, twice as fast as our interval, so the growth here is not going to be linear, but almost. And our metrics dropped as at 0. So we're still not dropping any metrics, which is fantastic. In fact, let's just match them up so that we don't get those false rewrites anyway. And what we'll do is we'll jump over here, and we'll actually just set this to 5 seconds so we can speed this up a little bit, and then we're not looking for me as entertainment. Which means we'll double our buffer limit just so that I can shut down InfluxDB and then force the drop metrics, but not too quickly that I can't talk about what's actually going on as well. So let's restart again. And we'll total logs, we'll wait for output. And I just had a thought, I haven't really tested the stream, so I know the video is being captured. I'm assuming people can hear me. I guess we'll find out soon enough. So let's jump back down to 5 seconds here. In fact, we'll just do a manual refresh to force it. And let's hopefully see some metrics. There we go. 21 metrics written to InfluxDB, and you can see this number is resetting every time we restart Telegraf, because it's essentially a new version of Telegraf. All the stats reset. So now we're at 36, 35, so forth, so forth, so forth. So that's all good. Now, what happens if now this is going to be difficult to see. I probably should have ran 2 InfluxDBs side by side so that I could show you them at the same time, but what we're going to do is stop InfluxDB, which means that Chronograph is no longer going to be able to fetch any metrics, but that's okay. So we want to trigger the metric buffer to go over. So let's just take a look at our logs, and we can follow this along here. In fact, we can already see the buffer fullness is 30 of 30 metrics. We're unable to write to InfluxDB. Now we're at the point where all of our metrics that are being written, or our oldest metrics that are being written to InfluxDB, are now being lost. They're being pushed out of the way in favor of the more recent metrics. At least I think that's how it works. I should really know that. InfluxDB. Oh, I do that every time. So now that InfluxDB should almost be healthy again, we should start to see all the metrics be written to both standard out and InfluxDB again. Yep, and our buffer looks good. Let's see one more. Yeah, I think we're good. So if we jump back over here, awesome. So now we can see we had 3 lines, and that's because our metrics being dropped was actually on the rise. And in fact, if we add our buffer size to this, we can see that our buffer hit 30 here, and then drops back down as InfluxDB comes back on, and then everything goes back to normal. So the metric buffer is a really simple setting within Telegraf that just gives you that kind of extra resiliency in case your InfluxDB or your, any other time series database that you're using goes down for any period of time. So the larger you make the metric buffer, the more memory you're going to consume. In fact, it's probably not worth showing it, just because we were only caching a very small amount. But if we take a look at the available percent and used percent, I don't think it's going to make a blip, barely. So let's go drop, nope, not filter, dropped, added, written, buffer, yeah. So the metric buffer just means that we can cache all of those metrics in memory in the event that we lose, like say there's a network problem or database goes down, anything that can happen within our infrastructure. Then Telegraf will capture them, hold on to them, and then retry as often as possible until it can write them back out to your database of choice. So it's a very powerful setting, and it takes like 3 seconds to configure. All you have to do is a little bit of math. Understand how many metrics you're writing per second. You can just take a look at this here, and we can see that we've got this linear growth. We want to work out what that is every second or every minute, depending on how often you've got your interval configured. and then say I want to be able to handle resiliency for up to 15 minutes, maybe even an hour, maybe 6 hours, whatever your failure scenario that you're comfortable with is. Multiply that by the number of outputs, and then use that as your metric buffer limit. And that'll give you resiliency with all of your metric collections, and hopefully you never lose any more data again. So this is just a short stream. I'm just testing this out. I hope you found it somewhat valuable. If you watched, please let me know. Let me know if starting from scratch like this was useful. If you'd rather slightly more larger examples or pre-baked first, I'd be happy to try that out as well. But thank you very much, and I will speak to you all later.